Hey guys, my name's Benedict. I made an iOS game called Dudeski with some friends. It's an arcade skiing adventure that's out on iOS right now. It has the structure of an endless runner, and I thought I'd give you guys a tech walkthrough about how the core pieces of functionality in the game work. So if you're interested in building your own endless runner, if you're interested in how Dudeski works, or if you're just interested in game development in general or Unity, this will hopefully be an interesting video for you. So here's what we're going to cover in this video. We're going to start off with just some context on the game, what it is, how you play, what happens in the game, so you have understanding of why we're implementing the things that we are implementing, or kind of, what they're trying to achieve. The second is how did we use Unity to build the game. So going through the scenes, going through the high-level outline of what everything does. And then from there, we're going to focus on three core pieces of the game, specifically how the patterns are laid out, and the core piece of that is the pattern manager, which determines level structure, laying out patterns, and moving all those pieces. And from there, we'll tie everything off with a recap of everything that we covered. So the first question is, what is Dudeski? Maybe some of you have played it before, maybe you haven't. So as I said, it has the structure of an endless runner. And here it is in Unity, playing in the editor. Alright, so you can see we're kind of skiing around, going back and forth, dodging obstacles. If we hit a bush, we slow down, hit some ice, speed up. So behind us there's an avalanche that you saw in the beginning. We're going around gates, going down different paths. As you can see on the right here, there is basically 4 different sections to this mountain. Each of them have their own challenges, and if you miss too many gates, then the avalanche gets you. So as I mentioned, there are 4 different sections to this mountain. You have the top of the mountain, the forest, Yeti Valley, and the totem trials. Each one, so top of the mountain has kind of more gates and gentler bushes. The forest has trees, which will stop you if you run into them. Yeti Valley has yetis and penguins, and then the totem trials have totems. And in addition, there's also item shops along the way. You're picking up pine cones so you can buy these items and make your way to the bottom of the mountain. So the game came out on March 13th, 2014. Did relatively well with the press, got the New Yorker's first iPhone game of the month, and good reviews from most of the major iOS review outlets. So now let's get into the meat of things and talk about how we used Unity to build Dudeski. So the game basically breaks down into 2 different scenes. We have the endless scene, which is where the game is actually played. We have a player object with some movement attached to it, a whole bunch of colliders and other things, a camera, really basic stuff. But besides that, there's not much going on. Some backgrounds that scroll, the avalanche that moves down to try and swallow you up. So really, on the surface, there's not that much going on here, besides player movement and a camera that follows the player. The place where a lot of the heavy lifting and kind of work is done is here in the test gate section scene, which is where we've laid out every single pattern that occurs in the game. So the way that the game works is that as you start skiing, there are patterns that are randomly set down in front of you to ski around. So for example, here we have all of the top of the mountain patterns. So these are some of the patterns that we just encountered on the short playthrough that I did. So for example, here's the first one. And each of these patterns is a prefab. If you're not familiar with prefabs, look it up. But basically, the general concept is it's a reusable object hierarchy, basically. So I can say, okay, here's the simple 1.1 prefab, and as soon as I drop it into the level, I basically get everything that you see here. Alright, and so each of these prefabs contains obstacles like bushes, some visual clutter like little pieces of snow and grass, some trees, and then each of these objects has scripts attached to them that perform behavior based on what kind of object it is. So bushes will slow you, trees will stop you, and that sort of thing. So we have everything laid out in this one scene. And this is nice because it gives us a nice visual overview. Editing things is kind of pleasant and easy. So say we want to change this forest pattern, and we're like, okay, this rock is killing too many people. We'll slide it in a little bit. All we do is change it here, hit apply so that it changes for all prefabs, and then any time that we run the level, every time we load this prefab, that change will take into effect. And so this is how then I can edit everything. And so now with this new understanding of how the game works, we can go back to the game and play again. And you'll see, okay, that introduction was a pattern. Here's a new pattern, those 3 rows of bushes. Here, these 2 pieces of ice with pine cones is one pattern. We see that first pattern again. And so all that's happening is we are appending patterns one after another as the player makes his way down the mountain. And that is pretty much the game. We keep appending patterns until they've hit a certain number, then they reach a new section. And yeah, keep going until you reach the bottom of the mountain. So with that basic high-level understanding of how we built the game, we can delve deeper into breaking down the 3 core pieces. The first core piece we kind of already touched on, which is the scene structure that we use, breaking it up between the endless scene where the player and the camera are, and then the test gate section scene where we are building all of the patterns that the player is going to encounter. The remaining 2 large pieces are actually scripts. One is the pattern loader, and the other is the pattern manager. The pattern loader is simply a class that contains a number of static arrays that hold the prefabs that we will be spawning. So for example, all of the forest patterns are split up into forest patterns 1, 2, and 3, these 3 arrays. Each of these 3 arrays, so basically forest patterns 1 is used in the first third of the forest section, forest patterns 2 is used in the second third, and forest patterns 3 is used in the final third. And this allows us to slowly increment the difficulty of the patterns, and so each of these 3 arrays holds a different set of patterns, each with increasing difficulty. So you can see that is kind of mapped back to the test gate section scene here, where we have forest patterns 1 through 5 here. So these are the easiest patterns. Then we move to the second set of forest patterns that are a little bit more difficult, and then finally this third set over here. And so all this class is doing is filling up these arrays with these prefabs that we are laying out in the scene over here. And we're just using a little convenience method called load and verify, which is loading the prefab from the path inside the resources folder. And so what that means is over here, we can see that the path to these prefabs is assets, resources, gate section prefabs, forest, and then here they all are. That is then mimicked here, and since it's resources.load, it's just gate section prefabs, whatever the section name is, and then the prefab name. So as I mentioned, the third core piece is the pattern manager, and that will be the most in-depth piece that we look into here. So what we're actually going to do is just walk through the class and see everything that it's doing to make the game run. So the first section here is just a bunch of class variables, the most notable of which are these indices marking how long, like the index of each section. So as we said over here, each section is broken into thirds, each with increasing difficulty. Over here, we then have a matching index to match, to decide when we are spawning which patterns. So basically determining at which point are we spawning forest patterns 1, at which point are we spawning forest patterns 2, and so on. And so that is then here mapped to these indices. So the forest patterns 1 index is the number of simple patterns total, so all of the patterns that occur in the previous section plus the default number of patterns. So each section has 30 patterns just about, and then those 30 patterns are subdivided into each third having 10. And so the index of the first set of forest patterns is basically from the simple patterns total plus the default number of patterns. And so that is then the index where we know that we have reached the end of the first section of forest patterns, and so on and so forth. And so the second forest patterns index is just this index plus the number of patterns in that third. So this then gives us indices that we can later reference for deciding which patterns to spawn at which point. And you can see these variables exist for every section of the mountain, so top of the mountain, forest, Yeti Valley, and totem trials. So the first method here is just this little setup method. It gets a bunch of variables that we need to hold on to, like the camera and the player. Nothing crazy going on there. And setting up the pattern loader, which, as we said over here, just loads all of these patterns into arrays. And then the first heavy lifting really happens here in the load initial patterns method. So the first thing that we do is we reset a bunch of variables. So for example, the first pattern that you always see when you're starting in a section is the introduction pattern. Resetting that so that if a player dies, they always see the introduction pattern as the first pattern when we reload the initial patterns. We're going to ignore a lot of some of the most difficult code is the code that handles the splitting of the paths. So in the gameplay footage that you saw that sometimes the mountain splits and we either choose a left path, which is more difficult, or a right path, which is less difficult. We're going to kind of ignore that because that's a little weirder and harder to explain in a quick video like this. So we'll be focusing just on the general case of arranging patterns because that seems like the most applicable to other people and the most interesting. Okay, so here then we start determining indices for special patterns. So for example, there is always a shop in the top of the mountain. And so we are basically determining an index for that shop by taking a random number between the second and basically a random number in the last third of the top of the mountain by generating a number between the simple patterns 2 index and simple patterns 3 index. We also, a bunch of this code is just checks that these special indices don't overlap with each other. So for example, we have a forest shop index and a forest secret pattern index. We need to make sure that they're not the same because if they are the same, then whichever one is assigned last is the one that's going to take precedence. And if we are spawning something, we want to make sure that it is spawned consistently. And so that is kind of happening here for every section. Here's top of the mountain, forest, Yeti Valley, and the totem trials. And then the last thing that we're doing is the variable that we use to keep track of how many patterns we've gone past is the num non-split patterns past variable. And this variable is used to keep track of where exactly we are in the mountain, so we know how far we've progressed when we cross into a new section of the mountain, that sort of thing. And so we have a class that manages where the player started off. So in Dudeski, you can unlock shortcuts to later sections in the mountains. And to make sure this works, we are basically setting a variable inside the scene preferences class. And so if the player started in the forest, we are starting the variable that keeps track of how many patterns are passed at the num simple patterns total. So that means we're starting the forest. So at that point, the game is behaving as if the player has passed every a number of patterns that exist in the previous section. And the same thing happens for Yeti Valley. The player has passed all of the patterns within the forest, and so on and so forth. Okay, and then once we have all of this variable set up, the absolute last thing that we're doing is creating the level patterns array, which holds all of the current patterns that exist. And then we're filling that array with the patterns that the first patterns that the player is going to encounter in the game. And so that then brings us to our next method, which is add pattern at index, which you can see is happening here at the end of our load initial patterns. And so here we're using the indices that we established before to see which pattern we are adding. And so this takes an index, and as you can see here, this index is starting off at the non-split patterns past. So the first index, for example, if you're starting in the forest, would be the num simple patterns total. And so it knows which pattern to add. And so if that index is less than the num-simple patterns total, it adds a simple pattern, or if it's less than the forest patterns, it adds a forest pattern. And so all of these methods right here, add pattern, blank, at index, all kind of do the same thing. We can go ahead and look inside one. So here we are then just determining which pattern needs to be loaded next. So the first thing is, remember that Boolean, those Booleans that we had in the beginning to determine whether or not an introduction had been shown. So if we haven't showed the forest introduction and we're adding a forest pattern, we're setting that to true so it doesn't happen again. And then we are filling this pattern array with the forest intro pattern from the pattern loader. And so this then happens for other cases. So for example, if the index is the same as the shop index, which was determined previously, we are filling the pattern array with just one pattern, which is the forest shop pattern. And the reason why pattern array is an array is because in the case where we don't have a special index, we are picking from a selection of potential patterns. So if we are not at an index that is a special index, we are just at a normal index, we then determine which third of the mountain we are in using our 3 indices here. So if we're in the first third, we are filling the pattern array with the potential first third forest patterns. And once we have our pattern array, either with one pattern for a special case or several patterns for a third of the mountain, we then call add random pattern from array with that array. Okay, so now we know which pattern we are adding. Now we need to actually load it to the level. And so we do that by using add random pattern from array. And so at this point, we need to determine which pattern within that array we're using. And so we do that by determining a random index from the patterns.length. So if it's a special case pattern, it'll just be 1, so the index will always be 0. And if it's longer, it will pick a random index. So if it's 5 patterns long, it will pick a number between 0 and 4 to pull out a random pattern object. So now that we know what index we need to pull the pattern out of, there's a whole bunch of work here that's kind of a lot of edge cases, but the really important part here is that we are simply getting a pattern object out of the patterns array that we passed in at the index. And so this, for example, right here is just making sure that we don't have any patterns, so we don't have any patterns twice in a row that are the same. So we take the last pattern here, we check its name to see if the name is the same as the new pattern that we're determining, that we are filling. And if it is, then we just keep determining a new index until we know for sure that the pattern is different. But that's not really the important part. The important part is just that we are getting a pattern object now. And so once we have this pattern object, we instantiate it into the world. And so what this does is it takes that prefab and it actually creates it in the game. And now we actually have a game object within the game representing that pattern. We set the X on it, and then we set the Y on it so that we make sure that it's in the correct position. And the Y position is determined by either the spawn Y. So if there have been no previous patterns, we put it at the spawn Y position. If there has been a previous pattern, the Y position is simply the last pattern in the current list of patterns minus the height of the pattern. And so this just means that we're stacking patterns one on top of each other, each pattern directly beneath the previous pattern, just by subtracting the height off of the previous pattern's transform. We set that position Y, and we add it to the level patterns array, which is holding all of the currently spawned patterns. So at this point, we have the beginnings of our game. We have spawned a certain number of patterns into the level that the player is now going to ski through. The only real remaining thing to do is make sure that we are updating the level properly. So once the player skis through a pattern, it just goes behind him, and so we need to do something about that so that we replace the patterns that the skier has skied past and are making sure that there continue to be patterns that the skier can ski through. And so we do this through the level in progress update. And all we're doing here is taking the first pattern and making sure, or checking if it is at a certain point behind the player. So we determine a Y value for this pattern at which the player has moved far enough away from it that it is time to destroy that pattern. So if that is the case, then we do some work here. Here's some more split pattern edge case stuff, but basically, if it's a regular pattern, we then increment our num non-split patterns past. If you recall, that was the variable that we kind of set at the beginning based on where the player started, and is the variable that tracks where in the mountain we currently are. And so, unless it's the last pattern in the game, we then remove the pattern that we just went past. The very kind of, as we said, once a pattern is sufficiently behind the player, it is removed from the game, and that's what we're doing right here, removing the last pattern being held onto by the level patterns array, and then destroying that object. And then, if we're not on a split path, this is again some split path code, we just add a pattern at the index, and that's the method that we already went over, and so from there, it just kind of keeps going on and on. The player skis, patterns are destroyed, new patterns are placed, until you reach the bottom of the mountain. Alright, and then so to recap, we have two scenes. We have the test gate section scene, which holds all of the prefabs that we're going to spawn on the mountain, each prefab being a pattern that the player has to ski through. The endless scene, in turn, has a player with movement attached, a camera here, and an avalanche that catches up with the player here. And the way that the prefabs are then put into this endless scene are with two scripts: the pattern loader, which loads the prefabs that we put together in the test gate section scene, and then a pattern manager, which determines where the patterns are placed, at what time, and continues to destroy patterns the player has passed and add new patterns in front of the player once they destroy old ones. And that's pretty much it. Thanks for watching this screencast. I really appreciate it. Let me know what you think. You can reach me at Benedict Fritz, or check out my website at benedictfritz.com. If you enjoyed the screencast and you don't own Dudeski, go to dudeskigame.com, and there's an App Store link right on there. I would really appreciate that. At the time of this release, we're probably going to be running a 50% off promo. But if you're watching this later, it's only $1.99 full price, so that ain't so bad. All right, thanks again, and yeah, see ya.